Good evening, everyone, and welcome to Social Flight Live. I'm Jeff Simon. We have a fantastic show for you this evening. Legendary astronaut, test pilot, aeronautical engineer, and air racer, Hoot Gibson, is here. This is the second time he's been here on Social Flight Live. We didn't even scratch the surface the first time, only talking about his time in space, and I am so excited to talk about the rest of his journey. As I mentioned, test piloting, aeronautical engineer background, and all that amazing air racing. We're going to cover it here on Social Flight Live. Before we get started, just a few housekeeping notes as we go into fall. We're seeing some of the coolest and most fun events starting to get added to Social Flight. So we're seeing everything from barn dances to pumpkin drops and you name it, it's all on there, and even events for the holidays with Santa Claus and candy drops and all sorts of other things for the kids. Go check out socialflight.com and the free mobile apps for Apple and Android devices. We have tens of thousands of aviation events and destinations, so many cool things to do. And in addition to that, we have all of the courses for wings credit that you can go on Social Flight and take. If you're an AMP and an IA, you can go and get your renewal for free with your certificates, get your 8 hours of continuing education, all in Social Flight. And we have our Fly to Win Challenge. That's where you check in at an airport using your mobile app. It gives you points, and you can compete to win in our drawing. And we are giving away a Lightspeed Delta Zulu headset tomorrow. There is still time. You can check in. All you need to do is go to your local airport, check in even once, and you are entered in to win. So be sure to go and check that out. And if you get multiple entries, you get on our leaderboard, you get additional entries in that drawing. And then we're going to give away, until you're not too late if you don't make it by tomorrow, we're giving away another Lightspeed Delta Zulu headset on December 1st, just in time for the holidays. So be sure to check all of that out. Tonight's broadcast is brought to you by Aspen Avionics with the Evolution Max primary and multifunction displays. We fly behind an Evolution 2000 system with both PFD and MFD in our Bonanza. We use that. We also got a PFD in the Mustang that's being built right here behind me. So very cool things, and you can check all of that out from Aspen. They just gave away an Aspen E5 electronic flight instrument through Social Flight. So again, we're just here to give away tons of stuff and help support General Aviation and all of you. Now to tonight's program. Robert Lee Hoot Gibson is a former American naval officer and aviator, test pilot, and aeronautical engineer. He was selected as astronaut by NASA in 1978, flew 5 missions with the shuttle, and these missions included the groundbreaking docking station mission with the Russian MIR space station. All that said, his crowning achievement may very well be serving as NASA's chief of the Astronaut Office from 92 to 94, one of only 4 individuals in history to have held the position at that time. However, Hoot's story extends well beyond space. As a professional pilot, a Reno Air Racer, and aviation experimenter, he has so many other things that we're going to be talking about tonight. It goes without saying, he was inducted into the United States Astronaut Hall of Fame in 2003, the National Aviation Hall of Fame in 2013, and has received several military decorations throughout his career. I am thrilled to have you, sir, with us here tonight. Please welcome to Social Flight Live, Hoot Gibson. How are you doing?
Hey, thank you, Jeff. Thanks for inviting me back. It was a lot of fun last time. I'm sure it's going to be fun this time as well.
The pleasure is all mine, sir, to say the least. And I want to go back because we indulged so much last time in your space career, your astronaut time at NASA, and everything that went into that. And yet, this path that takes you in what I'll call general aviation and post-military aircraft, the experimental world and all of this, that seems to have come as a genesis from your time in test pilot school and getting that aeronautical engineering degree. Would that be accurate? Can you tell me a little bit about that time?
Sure, Jeff. Well, you know, my goal from the time I was about 10 years old was I wanted to be my dad. My dad was an aeronautical engineer and a test pilot, and those were the 2 big goals that I had. I wanted to be a fighter pilot as well. And so graduated in aeronautical engineering from California Polytechnic in San Luis Obispo, California. So had achieved that. and then into the Navy, and through Navy officer candidate school, and then through pilot training. And I must have done well, because I got my first choice out of after I got my wings, which was F-4 Phantoms out of Miramar in San Diego. But still, I wanted to be a test pilot. And so that takes a number of years. That takes a number of years before you're going to get to be a test pilot. And so you had to have completed at least one cruise or one squadron duty term, which was about 2.5 or 3 years. And then you could apply to go to test pilot school. And so I got to do that. And Dad lived long enough to see me graduate from test pilot school. And actually beyond that, he lived long enough to see me go to space twice. And so those were the wickets that you had to go through if you wanted to be a test pilot. So I was so fortunate. I got to achieve the two biggest goals that I had set for myself. Notice that space wasn't one of the two biggest ones I had back then, but certainly the aeronautical engineering degree and being a test pilot.
So what was it about being a test pilot that attracted you? Was there an image that lived up to what it's really all about, or was it a little bit different?
Well, no, it has a very exciting image. And you know, there was the movie starring Clark Gable back in, I don't know, the late 30s, I think, called Test Pilot. And I had seen that movie, and that was fascinating. And he was an air racer as well. And so it really did live up to exactly what I hoped it would be. And I got to fly projects in the F-14 Tomcat, because even though the Tomcat was already out there in the fleet, there are always ongoing projects. There are incidents and accidents that happen out there in the world. And the Flight Test Center at Patuxent River, Navy test pilots are doing evaluations to answer, okay, why did this particular incident or accident happen? And why, what can we do to prevent further accidents similar to this one? And then there's new things. And the picture you've just put up was the new thing that I got to fly, and that was the Tactical Air Reconnaissance Pod System. And it made a reconnaissance version of the F-14 Tomcat. And it's visible at the very center of the airplane, back in the back. It's the largest external store that was ever carried by a Tomcat. And it was a multi-sensor pod that combined infrared and visual and maybe electronic as well. I don't remember. I didn't have the whole entire complement in the pod, but I was selected to do first flight of the TARPS pod, and then all the envelope expansion. And in this picture, you can see it's tufted. We have the whole bottom side and the tunnel area between the two engines tufted. And that's because the Navy didn't want to spend the money for wind tunnel testing. So the Navy said, well, maybe it's okay to do it without doing wind tunnel testing. We'll just be real careful. So Hoot, be real careful. And so since we hadn't done any wind tunnel work on it, we tufted the daylights out of the thing. And we saw that there weren't any real hiccups. And this was a picture taken as I'm doing the walk around before flying it. And you can see how big that pod is. It's 4 times bigger than I am. And so it was a huge appendage. And we weren't too sure about the aerodynamics, because we learned way back in the early days of the Tomcat, when they tried to drop bombs from back there in the tunnel, the airflow and the aerodynamics in between those two engines was really unusual, because they would pickle a bomb loose, and the bomb, instead of going down, might go sideways, might turn sideways, and drop a little bit and then come back up. And so the aerodynamics down there in the tunnel was really strange. We didn't see any big anomalies with the TARPS pod in terms of the aerodynamics.
Did it actually feel quite a bit different flying the aircraft?
It had a different feel to it, and of course it's slightly off center. So because it was picking up the attach points for the Phoenix missile, if I remember right, and so it wasn't right square in the center. So there was a little bit of an offset. And one of the anomalies that I saw was that at indicated airspeeds above 530 knots, it put a downforce back on the back part of the airplane, and I couldn't trim it out. I had to hold forward stick. So initially, I think there was a little bit of concern about that. Now, again, that's very high speeds, over 530 knots indicated. So the airplane didn't have enough nose down trim to eliminate the downforce that the pod was putting back at the tail end of the airplane. That was about the only anomaly we found.
What were some of the other more memorable things that you did during your test pilot time?
I had several interesting projects, and when I graduated from the test pilot school, I was selected to be the flying qualities and performance test pilot for the F-14 Tomcat. So anything that involved flying qualities and performance was something that I got to do. So one of my projects was we had an airplane out in the fleet that we think it had an electrical malfunction, and the Tomcat uses differential tail for roll control. So the two giant horizontal tails, I think they're bigger than the A4 Skyhawk's winged. And
Really?
so it uses differential tail and spoilers. When the wings are all the way forward, you need a whole lot more roll control power, because your moment of inertia is so much greater with the wings all the way forward. And there was a flight that reported that they had lost virtually all of their roll control authority. And so Naval Air Systems Command hypothesized that they had an electrical malfunction that disabled their spoilers. So it doesn't use ailerons when the wings are forward, because it doesn't have any. It's full span flaps and full span leading edge slats. So it uses spoilers when the wings are all the way forward. And an electrical malfunction could disable the spoilers, and that took away 75% of your roll control authority with the wings forward, so at slower speeds. So
wow,
this was a little bit of a high risk test, but of course we did this at altitude first. So we took it up high, and my back seater, who had been in my class going through test pilot school, Larry Balcom, who went on to be a rear admiral, by the way, after everything was all said and done. He and I flew the test flight with it, and we had a way that we could disable the spoilers in flight once we got up to altitude. Go ahead and disable them, and then see how the performance was, and the performance was horrible. It was such a slow roll rate that, you know, if you got in turbulence or a bad crosswind or something like that, you could really be in trouble. And we also were asked to say, okay, how can we help? We can use rudder. We still have differential tail, but how about asymmetric thrust? What if we bring up, if I'm trying to roll to the right, how about if I bring up the left engine? And that was one of the things that I found out, was that asymmetric thrust was really powerful. And in fact, you could get too much of it. But that was another way that we could help those out in the fleet if this happened again. Never heard of it happening again, by the way, but they could use asymmetric thrust, they could use rudder, and of course you've still got, like I say, differential tail.
Wow, that's really interesting considering how close the engines are together.
Well, they're actually 8 feet apart. And
so I guess it doesn't let, they're further than it looks.
Yeah, and what was funny, Jeff, was that, well, it wasn't funny, it was kind of dumb, really. The flight manual for the F-14 Tomcat said, the F-14 is essentially a centerline thrust airplane. No, it isn't. No, it isn't. There was an accident at Oceana where a Tomcat was taking off, And one of the weak points of the Tomcat was a vent tank back at the back tail end of the airplane, that excess fuel is always getting pumped everywhere through the airplane to feed the engines. And it would get fuel that we didn't use would get put into a vent tank back at the back. Well, when you did an afterburner takeoff, if the spring on that vent tank leaked a little bit, you'd get a big fireball behind you. And so Tower called the airplane and said, hey, your left engine is on fire. Well, it really wasn't his left engine, it was a vent tank. So he shut the left engine down. And then in maneuvering, which way do we pilots turn? We turn left. We don't turn right. We turn to the left. So he was making left turns to come back and land. And by the time he got near the runway and had about 90 degrees to go, he was getting a little bit slow. And he's at full gross weight, full of fuel right after takeoff. And 100% RPM on the right engine wasn't enough. You can see this coming. He lit the right-hand burner. And that yawed the nose of the airplane into the ground. And they ejected at the last second, but neither one of them survived. And so I was asked to do a flight test for that accident as well. And it involved using differential thrust, using thrust. And what I found was, let's say I put the airplane over in a steep left bank, and then I bring the left engine up to full afterburner. It rolled the airplane, but it also pitched the nose up for you. So the engines had 20,800 pounds of installed thrust each, and they were 8 feet apart. So it was not a centerline thrust airplane. So I wound up rewriting the flight manual to say the Tomcat is not a centerline thrust airplane. And so all the things that we know about multi-engine airplanes, avoid turns into the dead engine and things like that, applied to the F-14 Tomcat. So I'm the one that wrote the flight manual, and I bought a recent copy of it just a couple of years ago, and the write-up that I did is still what's in the Tomcat manual.
Wow.
So those were some of the interesting projects I got to do.
I can imagine. Oh my, that's amazing.
And it was a lot of fun. Oh, and the tarp pod. One of the things I had to do, Jeff, was I had to clear the structural envelope and the aerodynamic envelope. So I had to take it out to 1.65 Mach and 6.5 Gs at 1.65 Mach. And what was kind of funny was the very first time I did that, we were just offshore. We couldn't do supersonic over the Chesapeake Bay, which is where Patuxent River is. It's right on the Chesapeake Bay. So we couldn't do that because we boomed the daylights out of everybody. So I had to go offshore into warning area 108. But warning area 108 was only 4 miles offshore. So I was legal, but I was in warning area 108. And it turns out that if you're in a turn and you're creating these shock waves off the airplane, and in a turn, the shock waves will stack up together in one direction, and I boomed the daylights out of Ocean City, Maryland. And by the time I landed after that first test flight, the operations officer was standing by the airplane and the duty officer, and they said, the captain needs to see you right away. So I had done nothing wrong, but the admiral weighed in on as well, because anything involving Tomcats was really high visibility because Patuxent River had lost 2 Tomcats in accidents. And so anything involving the Tomcat got a lot of visibility. And the admiral said, okay, I know you were legal to be in 108, but you will move 30 miles offshore. And this was wintertime. And this was cold. And so we had to move 30 miles offshore to do all that testing. And all of it went okay. Now Patuxent River did not have a SAR helicopter, a search and rescue helicopter. But what they could do was they could use a Chinook. So they had a Chinook that would take off from Patuxent River, land over uh, Wallops Island, I think,
Hmm.
somewhere over there near, right by the Atlantic Ocean. But I'm 30 miles out to sea, and it's not a dedicated search and rescue helicopter. So if we had ejected and wound up in that freezing cold water, this was wintertime as well. Um, First of all, they probably would have never found us, but we wouldn't have lasted that long anyway. So I guess I'd call that kind of high risk testing as well.
Yeah,
But
man,
it
I
was a
can
lot of
imagine.
fun. It was a lot of fun, Jeff. And
Wow.
let's see, the final test flight was all the real high Mach number test points out at 1.65 Mach. And so we got a KC-130 from the Marines at Cherry Point. It came up there to be on station. So I'd go up there and burn all the fuel up, doing a test point at 1.5 Mach, go hit that tanker, go up and do it all again at 1.6 Mach, go back and hit the tanker, go out there and get 1.65 Mach and 5 Gs, but I needed 6.5 Gs. So I had to hit the tanker a third time and refuel. So, it's a pilot's dream to get to burn up all that much gas and go supersonic really fast and not run out of fuel.
So how does the plane operate at, I mean, you were exploring the VNE side of the envelope.
Well, we were defining a VNE for the tarp spot
Yeah.
is what it boiled down to, and also a structural limit because it was built to handle 6.5 Gs. So we had to verify that it would handle both the aerodynamic load at 1.65 Mach, as well as the G loading at 1.65 Mach. And so then that becomes a VNE. Now the actual VNE for the Tomcat was 2.4 Mach.
Mm.
So it was good for a whole lot faster than we were going to certify the tarp spot for. And I don't know how much use you had. Well, I guess they might have used the high Mach points in some of the combat in Afghanistan and over there. So they may have used some of the super high Mach points because they were concerned about surface to air missiles in the Gulf Wars.
Yeah. Wow. Well, that certainly gives you a pretty impressive baseline in terms of flight tests. And then tell me about how that connected to the work that you did in your personal life with experimental aviation.
Well, the whole time that I was at NASA, of course, that happened after my time in the Navy. Well, I was still Navy, but after my time at Pax River as a test pilot, I got selected in the first space shuttle astronaut class in 1978. And I had always been crazy about racing planes, racing airplanes, and air racing. And and I couldn't afford a P-51 Mustang to take it to the Reno Air Races or do anything with, for that matter. I probably couldn't afford the fuel that thing would burn, but I was able to afford a home-built Formula One racer, what they call the Formula One class at Reno, which is for an airplane that has to weigh at least, it has to weigh at least 500 pounds, all configured. And I bought one of those that needed to be rebuilt. And this is a picture of it when I first got it and was just starting to rebuild it. And it was called a Cassutt, which is Cassutt, named for the designer who was Tom Cassutt. And he lived in Texas and I met him and he designed this airplane. And I don't know how many of these have been built. I'm tempted to say there are at least 600 of these that have been built. And they had a very successful time at the Reno Air Races, flying in the Formula One class. The maximum size engine that you could have is an O200, so 100 horsepower Continental. So it had to be an 85 or a 90 horsepower or an O200, which was 100 horsepower. And this is what it looked like after I rebuilt it. I spent just
Wow.
about a year rebuilding it, and I always wanted to have a green and gold racing plane. And so all of a sudden, I've got a green and gold racing plane.
That is
And
just gorgeous, Hoot. I
and
love that.
oh, thank you. Yeah, and it flew as nicely as it looked. Stall speed wasn't too bad. About 80 miles an hour was the stall speed. Doesn't have flaps, so it's just a straight wing. And I raced it in regional races in Texas for about 5 years. And that gave me a little bit of air racing experience, having done that. But along the way, I looked at that wing, and as an aeronautical engineer, I look at that wing and I say that is a relatively inefficient wing. It's constant chord, which means the width of the wing is the same from the root all the way out to the tip. And you had to have 66 square feet of wing area. And so it was 15 feet in span by 5 feet in chord, or in the width of the wing. And that's not a very efficient wing design. And somebody told me that it was thought that, well, yeah, but the frontal area of it's really small because it's a very small span and it's only this thick. And so you have a smaller frontal area. Okay, well, that's not as important as lift to drag ratio and efficiency in the wing. So I designed my own wing and built it in my garage, and made it out of foam the way that a very easy wing is built. And I put a carbon fiber spar in it because I did a stress analysis, and I calculated that if I was going to build a fiberglass spar for it, the spar caps, the top and bottom of the wing spar, which is black in this picture, it would have to be 4/10 of an inch thick on each side of it. So carbon fiber is a whole lot stronger than fiberglass. And so for carbon fiber, it only had to be 0.15 inches thick, the spar caps. Now I made it thicker than that because I'm going to be flying this thing, and I want it to be really strong. And so you can see it's a tapered wing. It's got a 2-to-1 taper ratio. So the root chord that's right by me is twice as wide as the chord at the tip. And that's a quite efficient wing shape, and approaches the efficiency that an elliptical wing would give you. It's just about everything that an elliptical wing does. So I designed this wing, and this picture is taken before I had done the fiberglass skin over the foam. But I cut the foam cores, and you can see I put an aft spar in it, and that was to take out torsion, the twisting of the wing. And so that was my design. And when I finished skinning the wing, finishing all the fiberglass skin, I noticed, Jeff, that when I'd grab a wingtip and lift it up, I could see the wing bend under its own weight. And that made me a little nervous. So I decided I'm going to do a structural test. And so I did do a structural test. I took it down to the local lumber yard in Houston, and they lent me a pallet of cement bags, and I calculated what it would take to duplicate the loading at 7 Gs. And so I put 68 80-pound cement bags on that wing, 34 on each wing. And it's a flat wing, a perfectly flat wing. It's upside down in this photo because that's the direction the lift is going to be acting, is to bend the wing up, which is down in this picture. And you can see the wing bent about 10 to 14 inches, but it didn't break. And so I guess I really am a structural engineer. So it was 5,440 pounds of cement bags that was on that wing. And the thing that's taking all that loading is that black spar that's across it. The aft spar is not taking any bending moment at all. So it's not helping at all. And it's not designed to. It's designed to take out the twisting of the wing. So anyway, after it passed that test, I said, okay, great. I can take it to 6 Gs in the air and not be concerned about it. So that's what I did in the flight testing.
Wow, that is really, really cool. Help people understand from an aeronautical engineer perspective. We're all used to seeing wings taper as they get further out, as they get towards the tip. And you mentioned the 2-to-1 ratio. What's the reason? What's the science behind that as to why you don't do something that's just like a Hershey bar wing?
Yeah, it has to do with the lift distribution. And so it turns out that an elliptical shaped loading is going to be more aerodynamically efficient than a square loading, where you've got the same load from the center section out, and then it gets out to the tip, and then it suddenly drops off to nothing.
Hmm.
So a bit of an elliptical loading is why you're doing that. Now, an elliptical wing gives you the most perfect elliptical wing, and it's rooted in mathematics, but it can be derived and shown that an elliptical lift distribution is the most drag efficient way to
Hmm.
produce lift. But a 2-to-1 taper ratio comes awfully close to it.
So that's why maybe the
And
Spitfire did something like that.
oh, the Spitfires went to all that trouble. Yeah, and it made a really pretty looking wing, but it is complicated and complex to build. And all I had to do was cut foam cores in straight lines by doing a 2-to-1 taper ratio.
So
And,
it has a lot
and
to do with like wing vortices and drag that happens at the tip.
yes, all of that factors into it. Yeah, so the tip vortices coming off the tips are much less in a 2-to-1 tapered wing, whereas in a square wing, you've got the loading trying to go out all the way to the tips, and then it suddenly dumps, and so you've got a big vortex coming around the wing tips
Yeah.
in a Hershey
And then
bar wing.
as you mentioned, the further out you get, the less load you have to carry, and so you can have a lighter and lighter and lighter wing further out.
That's correct. And so the the carbon fiber spar, at the center section, I think, Jeff, was like 35 plies of unidirectional carbon fiber. Out at the very wingtip, it was 1. And so it dropped every, if I remember right, and I'm sure I do, every 5.82 inches I would drop a ply. And this is what the wing looks like on the airplane. So it makes it a better looking wing as well than
It
the
does.
Hershey wing. Now it's fiberglass, so I couldn't put it in the green color because that would get too hot out in the sun. And if you get fiberglass, even after it's cured, up over, I don't remember what now, 100 and 190 degrees, the resin starts to soften a little bit and the wing will change shape on you. So
Mm.
it had to be a light color. I didn't want a white wing, so I said, okay, I'm going to go with a pale yellow wing. And that's to protect it when it's out in the sun, which is most of its life when it's flying. So anyway, that's why it isn't green.
Oh, I didn't realize that was the reason. That's really interesting. Very cool. But it definitely
Yes.
gives it a very, very interesting look.
Yeah. So if you look at the very easies and the long easies, they have a wing built. I built my wing the way they built the wing. They cut a foam core and then do all the work to it. And if you notice, the long easies and very easies, virtually 100% of them are white.
Right.
And that's because with a room temperature cure, which is what we're doing, if you had an autoclave or a hydroclave and you could cure your fiberglass resin in that, I understand that can go to a lot higher temperature. But a room temperature cure, you can't let it get too awfully hot. So it needs to be
Yeah.
lighter colors.
Wow. That's really amazing.
So that's what went into all that.
So help me connect now the racing that you're doing and the experimenting that you're doing with the cassette to kind of how that evolved with work like Bruce Bohannon, with the racing that you did. What was the order of events there?
Well, I had, like I mentioned, Jeff, about 5 years of experience flying in Formula One air races. And I met a man who had bought a Hawker Sea Fury, which is bigger than a Bearcat. It looks similar to a Bearcat. In fact, people walk up to it all the time and say, this is a Bearcat, right? No, it looks very similar. It has a big radial engine in front. But the stock Hawker Sea Fury only has 2,400 horsepower. Only 2,400 horsepower. The engine is a Bristol Centaurus, British engine, and it only has 2,400 horsepower, but it's not quite as robust. And so everyone that's serious about racing them puts in a Wright Cyclone, a 3350, R3350. And that's what was in riffraff. And in this picture, I'm leading another Hawker Sea Fury. I'm in the red and white one that's in front. And good friend, dear friend for many years of Reno Air Racing, Stuart Dawson, is flying his airplane, Spirit of Texas, behind me. And he wasn't always behind me. There were a bunch of times I was behind him. And so we were both very competitive. And the 3350 puts out 3,000 horsepower instead of 2,400. And so makes for a pretty darn fast airplane. And so, and it's a much more robust engine than the Bristol Centaurus engine. So anyway, Mike Keenum was the owner of that airplane, and he was going to race it himself. And his wife said, I don't know, that sounds dangerous. And so he said, okay, tell you what, let's do this. 1995, he said, let's go watch the Reno Air Races and you'll see it's all just fine. Well, you can see this coming. They're standing there watching one of the T6 races, and two of the T6s collided, and one of the pilots was killed. And the way he describes it, she turned and looked at him. Her face was white as could be, and she uttered just one word, never. And so he kind of went away disappointed. And then he got to thinking, and he went back to her and he said, okay, how about if we find somebody expendable, somebody we could never possibly get attached to, and we'll let him race it for us. And so Mike asked a good friend of mine named Chuck Scott, hey, do you know anybody that has a little bit of racing experience? And he mentioned me. And so Mike asked me if I'd be interested in racing it. And this is what Riff Raff looks like, the picture that we're looking at right now. Gorgeous paint job. And Mike's wife, Kay Keenum, came up with the name of it. She said, well, we're the new kids on the block. We're the new guys. We've never raced before, so we're the Riff Raff. And so race 99, Riff Raff. I raced that airplane 10 years altogether. And we started back in the middle of the pack, middle of the silver category. And after 3 years, we bumped up into the gold category, which is the 8 fastest airplanes at Reno. And I had 3 fourth place finishes. It wasn't quite fast enough to beat the really hopped up Mustangs, but it was sure a fast airplane. And I think we averaged 388 miles an hour the first year we raced it. And the last year we raced it, I think I did 445. Wow. And now that wasn't me doing that. That was Mike Keenum, the owner, who continued to put aerodynamic modifications in on that airplane. And it got faster and faster every year. And he actually got to race it himself. He decided a couple of the years that we were out there at Reno, his wife hadn't come out there yet. She wouldn't come out until the final days of racing. And so he actually called her on the phone and he told her, hey, I'm going to fly it in the heat race today. And she had a bit of a meltdown and all, but she knew she couldn't tell him not to do it. And so he did get to race it a couple of times. Now, the way he describes it, Jeff, he said it was funny. He said his knees were shaking so bad, getting ready to start the race. And then when he finished the race, came back in and landed, he had to sit in the airplane for about 5 minutes after he shut the engine down. He said so that his knees could stop shaking. But he was a dear friend, and he's the one that was responsible for me getting to race in the unlimited class. And the unlimited class, I should mention, when I was an astronaut, I'd get interviews all the time, and people would say, okay, you were a fighter pilot, you were a test pilot, you're an astronaut now. Is there anything in the world of flying that you haven't done that you'd like to do? The answer was always, I would dearly love to race the unlimited class at Reno. And Mike Keenum and Kay Keenum made that happen. And I raced Riff Raff, like I say, 10 years. And air racing is kind of exciting. And then they needed to move on, so they sold the airplane. But then I got to race this one, race number 232, which was actually the fastest Sea Fury ever to race Reno. And part of the reason that it was the fastest was it didn't have an air-operated oil cooler. In other words, where the oil cooler had to suck in air and run it through the cooler and dump it out. That's a lot of drag. This one had a boil-off system. So it had a boiler mounted in the aft fuselage, and you can just see there's a little round opening just aft of the canopy and in the middle of the fuselage. Yes, right. Actually, down in the yellow part, there's a little round hole. That was the steam exhaust for the water boiler that operated the oil cooler, that cooled the oil cooler, cooled the oil. And other Sea Furies all have a big opening in the leading edge of the left wing, and you can see in this picture there's no opening near the fuselage where the oil cooler would be. So this airplane had less drag than any other Sea Fury out there. It was even faster than the two Sea Furies that had the R4360 engine in it, 4,000 horsepower, but it had to have two oil coolers, one in each wing. So as a result, 232 with just a 3350 in it was the fastest Sea Fury ever to race Reno. And I raced that 4 years. The engine blew up on me 3 of the 4 years, but the 1 year it didn't blow up, I got second place overall. So it was a fast airplane if we could keep the engine from blowing up. But you know, that's air racing.
You've had more dead stick landings that I've heard about, either from you or from Bruce Bohannon or from others, than most people I know.
Yeah, Bruce Bohannon has had a lot of them as well, but you know, you really get dead stick landings out of air racing because you are pushing that engine so hard. In Formula One, you know, we're running an 0200. That's a Cessna 150 engine, and it's run at 2,800 RPM in a Cessna 150. For racing, we run them at 4,000 and 4,100 RPM, and so you're pushing those engines really hard, and sometimes they say, okay, I've had enough, I quit. And so that's why we practice dead stick landings all the time. Because when you really get one, you really need to be able to know what to do. And the last one I had was in 232 in 2014. That was the last year I got to race 232. And from the time the engine blew up until I touched down on the runway was 1 minute and 26 seconds. So it's going to happen fast, and you better know what to do. So you better have practiced a dead stick landing because especially the big Sea Furies, that's a big heavy airplane, great big radial engine up front with a lot of drag, 14-foot diameter propeller, which when there's no engine turning it, that's called a speed brake. And it sucks up so much energy out of the airstream that you know, you don't need speed brakes. You don't need a drag chute. Your problem is going to be you're going to come down like a space shuttle. And 1 minute after, well, let's see, the first 1,000 feet I descended that last time the engine blew up, I came down at 6,000 feet a minute for the first 1,000 feet, and for the second 1,000 feet it was 6,600 feet a minute. So it's going to happen fast, and so you better have practiced it and be pretty good at it.
Wow.
But you know, Jeff, I was needing to replace a space shuttle for excitement, and so I think it had to be something like this.
No kidding. And then, I mean, what was it like though, transitioning like the first time? There's a big difference between a Casset and some other stuff, and all of a sudden hopping into a Bearcat or a Sea Fury. What was the transition?
It was a big change. Yeah, it was a big change, and one of the ways I trained for it was flying a T6. And what the owner said, and actually what the class president, Art Vance, said, you know, a good way to check out in a Sea Fury would be to go fly a T6 and do touch and goes from the back seat of a T6, because the Sea Fury has got that huge radial engine and a great big giant cowling, and right at touchdown you can see over the nose a bit, but as soon as you slow a little bit and that nose comes up, you're not seeing anything in front of you, and so you're having to steer looking at the edges of the runway and figure out, okay, I'm still in the middle of the runway, and things like that. And so, but the other thing was I had to go fly with Ralph Royce. I don't know, do you know Ralph Royce?
I do not.
Well, he's another aviator from Texas, and he's an interesting personality. And so I had to go do backseat landings in the T6 with Ralph Royce. And the T6, if you can land a T6, I think you can land just about anything. That is a challenging airplane to land, especially if you've got a crosswind.
That is what
Because
everyone says. It's like you talk about going to the Mustang, you talk about going to anything, everyone just says T6.
those are easier than the T6. And it's particularly true in a crosswind, because what happens with the T6, you let the wind get under that upwind wing, the struts are soft enough that it'll compress the downwind strut. And now it really wants to go downwind. And so, yeah, the T6 is a challenging airplane in a crosswind in particular. And it's even more challenging from the back seat, having to fly touch and goes in it. But once I had successfully done that, then I did a checkout in a 2-seat Hawker Sea Fury. And Dennis Sanders, a well-known racer at Reno in Sea Furies, did my checkout in the 2-seater. And at that point, now, okay, I'm cleared to go fly the single-seat Sea Fury. So that was how I got cleared to fly the thing.
Wow. So tell
And
me
it was
how
worth
you
it.
tell
It
me how
was
you
worth it.
evolved then to get to Strega.
Oh golly! Well, you know what happened was Tiger DeStefani had been after me for years, 3 years, saying, "Hey, Hoot, when are you going to come race? When are you going to come race Strega for me?" And I was tied to 232 at the time, and I said, Tiger, I said, I can't bail out on my team. They've put a lot of time and effort into training me, and I can't leave them. Well, what happened was the last time I blew up the engine was in 2014. The owner of the airplane decided, okay, I'm tired of buying engines for Hoot. Now, you know, I wasn't causing them to blow up. It was the racing that was doing it. It was pushing them as hard as we were. And so he finally said, okay, all right, I give up. We're going to sell the airplane. Tiger called me the very next day and said, okay, now there's no reason you can't fly Strega, right? And I said, yes, you're right. Because I really was tempted to fly Strega because I knew it could win the championship. You know, if everything went my way and everything worked well, and if I didn't mess it up, I knew it could win the unlimited championship. So I wanted to do that. But like I said, I wasn't going to leave my team. Well, once the team dissolved, that's what put it all in motion. So I had not flown the Mustang other than 2 times previously. With one of the best flight instructors I've ever known, Lee Louderback, and his operation Stallion 51 out of Kissimmee, Florida.
Mm-hmm.
He is one of the absolute most professional instructors and aviators I've ever had the privilege of flying with. Anyway, he checked me out and signed me off in the P-51, and then I got to fly Strega. And a P-51 Mustang compared to a Hawker Sea Fury, the Mustang is such an easy airplane to fly. You have all kinds of field of view out of the cockpit. It doesn't have that giant radial engine out in front of you. You can actually see by leaning to the side a little bit, you can see in front of you somewhat. And it's also a whole lot gentler flying airplane. Now, Strega has a clipped wing. And so I'm thinking, oh man, a clipped wing, that's going to have a really fast stall speed. 90 miles an hour was the stall speed. Because in addition to clipping the wings, they had removed so much weight out of that airplane that I was really surprised. My Cassett stalls at 80 miles an hour, and Strega stalled at 90 miles an hour. So I was expecting 120, 130, but no, 90 miles an hour, even with the clipped wing. So it was such an easy airplane to fly. Now, racing it, that was complex because it has a water spray bar for the radiator and the oil cooler, which are both in that tunnel down under the wing, which all the Mustang pilots refer to that as the doghouse down there. And it generated so much heat that it had a water spray bar for those two coolers, or else you weren't going to be able to keep the engine cool enough. And then it had water methanol injection to keep from blowing the tops off of the cylinders at 128 inches of manifold pressure, which is how much power I was running.
Wow.
And I asked Tiger, I said, when we got to Reno for qualifying and getting ready to race, I said, Tiger, how much power do you want me to use? And he said, well, WFO, we're here to win. So WFO, well, which stands for wide freaking open, I'm sure, is what it must stand for. And so that was full throttle. And it's interesting, in World War II, the Rolls-Royce Merlin, which is what I was flying, now this was a highly modified Rolls-Royce Merlin, full throttle was 69 inches of manifold pressure. And if you broke a copper wire guard, you could go to war emergency power, 72 inches. So I was running nearly double that in Strega. And the way they get that, I don't know all the secrets for how you hop up a Merlin. I know that they increase the gear ratio to the supercharger. So therefore it's spinning faster. And it puts out a whole lot more, obviously, induction air, 128 inches of manifold pressure. So that's 4 atmospheres. That's over 4 atmospheres of boost. And in the Mustang, if it'll hold together for 8 laps, you're probably going to win. And this picture was when I was flying it in 2015, which was the last year I got to race. And I'm dueling with Rare Bear, which is a really fast airplane as well, highly modified Bearcat. And it has won the Unlimited Championship, I don't know how many years, I want to say 15 years altogether, that Rare Bear has won the championship. And I was struggling initially to get past Rare Bear. In fact, I couldn't get past him. And I'm convinced that the reason was we had not thoroughly broken in that brand new race motor. It had 3 or 4 flights on it before I started flying it with the race motor in it. And I flew it 2 times before we went to Reno. And then I flew it from Bakersfield to Reno. And then the next time I flew it, I guess I got to fly a practice flight in it, but I wasn't using high power. I wasn't full throttle. And so it just had not really seated yet. And I finished qualifying, and I finished second behind Rare Bear for qualifying. And then didn't have to race in the Thursday heat race because I was one of those, I guess, 6 fastest airplanes. But in the Saturday heat race, I could not get past Rare Bear. And then, I'm sorry, the Friday heat race, I could not get past Rare Bear. He was in front of me and I couldn't pass him. And then all of a sudden in the Saturday heat race, that engine came to life. And I cruised right on by him and was actually throttling back for the rest of that heat race. And then on Sunday, the final race, I walked away from the rest of the pack and I lapped everybody except for Rare Bear. Rare Bear was the only airplane I didn't lap, and he got second place. The water spray bar I mentioned is showing what it does in that previous picture where it's just the Mustang by itself, that trail of steam that's behind it. Yes, that picture, that's showing all the steam that's being produced in the spray bar for the radiator and for the oil cooler coming out of the doghouse underneath the wing. So, but the other picture, we refer to air racing as uncooperative formation flying, because in those pictures where I'm climbing all over Rare Bear, he doesn't want. In this one I'm flying the Mustang, and I'm climbing all over him, and I don't want him in front of me, so I don't want him there, and he doesn't want me where I am. So that's why it's referred to as uncooperative formation flying. So that's what air racing is like. looks in this picture like we're pretty darn close, and we are. We're pretty darn close together. But I can't go to the outside of his flight path, or I'm flying a much longer circuit around the race course. So I've got to stay on about the same course that he's flying, or else I'm flying too great a distance, and I'm not going to get past him. So
How do
once that
you?
engine came to life, I just walked away from the rest of the pack. So that was exciting once it finally came to life.
And what is the route? How do you pass someone?
You have to pass on the outside. It is a huge no-no to pass on the inside of the turn. So you have to pass to the outside of the turn. And sometimes it takes several laps. The earlier picture that we had of me in riffraff with a silver P-51 Mustang in front of me, I was trying to get past Jimmy Leeward in his Mustang, and it must have taken me 4 laps to get past him. But sometimes you just had to be very, very patient and work everything and be really smooth. Don't be all over the rudders, or else you're yawing and you're causing drag. And of course, all the while that you're doing all this, yeah, this was the picture of me racing against Jimmy Leeward, and I eventually got past him. And this picture is interesting because there's one of the pylons, and I think this was pylon number 8, which is the final pylon before the home straightaway. And it's interesting, the rule for minimum altitude is that my helmet must not be below the top of that pylon. My helmet must not be below the top of the pylon, which I see as a reasonable rule for minimum altitude. And in this picture, Jimmy's not a whole lot above the top of that pylon. He's maybe 20 feet, maybe 30 feet, and I'm probably 40 or 50 feet above the top of that pylon. But it is exciting to fly low, and I don't fly low any other time than air racing, but it is exciting.
Wow. And of course, that resulted in you taking home.
Oh, yes, Racing Strega in 2015. This is the permanent trophy, so I didn't get to keep that one. That would have been nice to keep that one, although I don't know how I would have got it home. What happened with this picture, Jeff, was this was right after I had shut the engine down and climbed out of the airplane. Now, even though I got the checkered flag, you never know whether you got called for a pylon cut or a deadline cut or something like that. But what had happened right before this photo was the announcer came up on the air and said, okay, the contest committee has just told me that we had a clean race, and so we have a new national and world unlimited champion, Hoot Gibson. And the crowd started screaming, and so I was waving at the crowd, and that's when, let's see, who took this picture? Jared Ulrich, talented photographer, shot this photo just as I was waving to the crowd. So,
Wow.
So anyway, that was an exciting moment, because you think you won the race, you haven't won the race until the contest committee says, yes, you won the race. So that was the moment right before this photo.
That's amazing. Absolutely amazing. I really love that. You know, obviously, I'd mentioned at the beginning, you're probably going to have to come on again.
Yeah, we did mention that, Jeff.
we didn't get. I want to talk just for a minute, especially as tribute to your very, very good friend, and also my friend Bruce Bohannon with Pushy. And Bruce was on SocialFlight Live, was on this show not long before he passed away, and you did quite a bit of work and time with him. I'd like to spend some time in a different episode where we go in more detail, but could you talk a little bit about that time that you spent and the records you set?
Sure. Well, Bruce had contracted with Jim Miller to use his molds and for Bruce to build one of the Jim Miller pushers. And this shows it in a configuration where Bruce had modified the wingtips. And let's see, I guess that's the big modification in this photo. But you know, it almost didn't happen, because Bruce took Pushy to the Reno Air Races in 1989, and Bruce also owned a cassette racer, and he couldn't race both of them, obviously. So he asked, would I be willing to race his cassette racer at Reno for him? And I said, well, sure I would. And so now it turned out poorly for Bruce because I wound up beating him because he was having trouble with the engine. And in fact, I had to lend him the engine out of my cassette because he had blown his engine. And he said, Hoot, old buddy, old pal, can I have the engine out of your cassette for Reno? And I said, sure, Bruce. So anyway, we pulled the engine out of my airplane. He put it in his racer. And so it wasn't souped up very much. And so he had a little bit of trouble with it. But we went to the races in 1989, and there was another Jim Miller pusher racing, flown by a pilot named Earl Roberson. And in the Friday heat race, he was going around the pylon, so he was pulling G's, and he went through a dust devil, and the left wing ripped off the airplane.
Oof.
And so Bruce is there that year, and so we watched that happen. We watched him hit the ground. And of course it's unsurvivable because you're over 200 miles an hour. So Bruce had a lot of concerns about the airplane, about the design. And so
he told me that and talked about it during the show. He said he was very, very scared of that plane.
Yeah, well, anyway, he asked me to look at the structure. So I got some photos of the structure, and I talked to the crew chief, who told me how big the steel tubing was, because the wing spar was chromoly tubing. Hardly anybody has a wing spar that's chromoly tubing, but it was a lattice work of circular chromoly, and he told me the dimensions of the piece, and I did a calculation, and I calculated that wing should have failed at 5.5 Gs, which is probably exactly what it saw. 3.5 Gs for the turn, and then maybe another G.5 for the dust devil that he went through, and that ripped the wing off. So I designed a structural modification for Bruce that he implemented into it to beef that thing up to where it would be well over 7 Gs. Now, supposedly that airplane had been demonstrated to 6 Gs, because that's what you had to do to race at Reno, was demonstrate with a G meter in the airplane, go up and show an observer from Formula One that, yes, you put 6 Gs on the airplane. Apparently that had never been done. Somehow Jim Miller had slipped by the structure of the race and the structure of Formula One, and somehow he had managed to get in there and race it for some years without ever having demonstrated the 6G pull-up. Wow. And so I helped with that. I designed the fix, the structural fix, that beefed up the whole wing spar. We wound up, what we did was putting another steel tube inside the steel tubing that that made up the piece that had failed. Wow. So, and Bruce did all that. I just designed what we needed to do. So anyway, and that let him race that airplane very successfully and finish as fast as second place in Formula One.
Well, Hoot, there's a whole other category of record setting, of talking about pushy galore, of some humorous comments that Bruce told me about you losing a prop on the back of it, and how you decided a shuttle pilot doesn't declare an emergency, you just land back at your original airport. I would love to cover all that if we can get you back sometime, and maybe towards the holidays.
Sure, we can do that. We can do that, Jeff. Yeah, that'd be fun, because there's a bunch of stuff to talk about pushy, and we didn't talk about the 2 world records I set in my cassette. So
that's exactly what I want to get to. I want to talk all about record setting.
There's a whole bunch of that stuff to go.
I know. We made it through racing. That's a goal. We tell everybody we're going to do all 3 of these topics. We got through some flight tests. We got through some Reno racing there. But it's all a trick, because we just want you to come back.
Okay, it's a deal. These are fun. So yeah, I'll be happy to.
Absolutely. We'll be back, and it'll all focus on record setting, and we'll talk about what you did in the cassette to set those records, both for everyone as a little teaser there. Altitude, horizontal flight. I mean, you set world records in that we're going to talk about how you did that, how you designed for it, and then how you even did, again, the work with Bruce as well.
Sounds great. Sounds great, Jeff. I'm up for it.
You got it. Well, Hoot, thank you so much again for joining us here on the show and for giving everyone this wonderful teaser for another visit, because it is really a personal joy of mine to get to spend an evening with you talking about such amazing things, and I really am truly grateful.
Well, and they're fun to talk about, as you know. And so yeah, so count me in, Jeff. I'll be back.
Well, you know, you do the hangar flying and all your stories are true. We all go talk about it on our own, and you never know what's really happening.
Well, yeah, it's all true. Yeah.
All right, Hoot, you have a wonderful evening, and thank you so much again for joining us on SocialFlight Live. We'll see you again.
It's a pleasure, Jeff, and I agree. I'll see you again. Thanks so very much for inviting me.
Take care.
Okay,
bye.
Bye-bye.
And to all of you, thank you so much for taking time out of your evening to join us here again on SocialFlight Live. We'll be back next Tuesday, October 7th here with Avionics' Shane Woodson. They've got some amazing new products they're working on, because there's some news coming out of, if you want to look it up, look up the Part 108 rule and why you need drone repellent for your aircraft. Yes, drone repellent. Yep, you'll see what that means in terms of avionics. We'll learn from Avionics what's happening with regulations. Very, very cool things. That's next Tuesday, October 7th at 8 p.m. again on SocialFlightLive.com. Then the following week, October 14th at 8 p.m., we have our Cockpit to Cowl show. We're here with Brian Schiff. We're going to be talking about breaking the rules for safety. And there are some very, very important times that you should be breaking the rules for safety. We're going to cover all of that. We're going to also be coming to you from MBAA out in Las Vegas. And so that'll be a really fun show. To sign up for that, please go to Cockpit, the number 2, and the word cowl, cockpittocowl.com. Until next time, thank you so much for joining us this evening, and I wish you all blue skies.